Hi, I'm Jordan.
And I'm Kit.
Welcome to Starry Time, where stars plus lines.
Equal stories.
In today's episode, we'll be talking about the astronomy and other cosmic background of the constellation Leo Minor, or the smaller lion.
I really feel smaller lion in my, deep in my heart.
No, Kit, we are big lions. Huge lions.
Leo Minor is a small and faint constellation in the northern hemisphere.
It is 232 square degrees, ranking 64th out of the 88 IAU recognized constellations in terms of size.
Well, it's bigger than Sagittarius, so that's something.
I mean, a great downward comparison, Kit. Yes, the smallest lion is still bigger than Sagittarius. Yes.
The stars in Leo Minor were actually designated by our friend Ptolemy as part of the Leo constellation, but they weren't really part of the constellation outline. They were kind of just like floating out there in the bounds of the constellation more broadly. So we actually have Johannes Hevelius to thank for this little lion.
Oh, Johannes. And, of course, do not get him confused with our other favorite Johann Bayer.
Mm-hmm. Right.
But be sure to listen to more about Johannes Hevelius in our Link's Cosmic Background episode, where we talk about him and his star castle, aka Sternenberg.
Yeah, we got Hevelius lore for you in that back catalog. But in this case, he proposed Leo Minor or Leo Junior along with 10 other constellations in 1687.
Some of them stuck, like Leo Minor and Lynx. Who doesn't love a cute kitty? But other of his proposals didn't. It's kind of a shame because while I'm not a fan of some of his selections for new constellations, like Triangulum Minus,
Mm.
which I have to assume is a small triangle,
Mhm.
he also came up with the constellation for Cerberus, which would have been a great constellation name.
Yeah, Cerberus would have been really, really good. Small triangle is less good.
It's room for improvement, our guy. Room for improvement. They can't. Some of them are gonna be stinkers, Johannes.
It's true. Richard A. Proctor, who was an English astronomer who lived from 1837 to 1888 and is known for making Mars maps, also did not find Leo Minor very compelling. So in 1870, he proposed renaming Leo Minor Leana or the Lioness.
I mean, on one hand, I love it.
Mm.
Why shouldn't we have a lioness in the night sky? Right?
Hmm.
But then, of course, the inference or the deduction is that it was basically like, what's it called? Where they just throw out a piece of meat. A charity
Mm.
case where basically nobody who called it Leo Jr. wanted to call it Lioness.
Mm.
So it's kind of like he was trying to make an effort, but only half-heartedly.
Yeah, it's hard to sort of like read into the motivation. Like, does he just assume that a smaller lion is like automatically going to be a lioness? But I think we shouldn't read too much into his motivation because he's on record of saying that like his goal was just to shorten the names so it was easier to make the maps.
Well,
Mhm.
printing costs are expensive, and I love Leona. But anyways, Richard A. Proctor, we're keeping an eye on you.
In the meantime, let's talk about first impressions. What did this one look like to you, Jordan?
This looked exactly like some of the fishes I drew when I was like 5 or 6. It's got a big fish body and then a tail. So to other people, it might look like a long triangle and then a tail. But to me, it looks like a little baby fish swimming through the galaxy. A little minnow, a little Leo minnow. How about you, Kit? What did you see?
I like little fish, like hand-drawn fish. I guess I
Yeah.
kind of went with a sideways kite, an angular spoon.
Hmm.
Um, can't really see lion of any kind here, so I must just lack imagination.
Yeah, I wouldn't even know which side would be the head, to be honest. The entire lack of limbs also
Right.
makes it difficult to
Yes.
see as a lion. It would be a great stellar tortoise, perhaps, or
Mm,
snail. Like it
mm,
looks a lot like an animal with a head and like a boxy body.
yeah. Well, I'm not sure that our descriptions are super helpful, so I think it will be good if we got technical.
Leo Minor has a right extension of around 10 hours and a 30-degree north declination.
It's located between the constellations Ursa Major and Leo, and it shares a border also with Lynx.
It's visible at all parts of the northern hemisphere through negative 55 degrees latitude. And if you want to see it, the best time would be during April nights.
Now that we know a bit more about the history of this constellation, where to find it, let's talk about stars. There are three main stars of this constellation, which have a magnitude brighter than 4.5. But our guy Bayer wasn't on the job to designate these ones.
Who was it this time?
It was our friend, Francis Bally.
Francis Bally. He was the one who gave the single star a Bayer designation when we talked about links, correct?
Oh, yes, and he's back at it again here with Leo Minor, giving only one star a Bayer designation.
Why do we think he went this way?
I don't know, but I guess he died before he revised his work. So.
Excuses, 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 Francis.
Yes, because he only did one designation, and it was for Beta Leonis Minoris.
Beta, wait. He did one Bayer designation. One. And it was beta? It wasn't even alpha?
Yeah, it seems sort of sloppy, but I don't know what his methods were.
They were poor, Kit. His
Mm.
methods
Mm.
were poor. Is this at least the brightest or the second brightest star? Or, like, didn't even get in the ballpark?
It is indeed the second brightest star.
So nailed it. But this section is about the brightest star. What is the actual brightest star?
So the brightest star does not have a Bayer designation. It is known as 46 Leonis Minoris, and the number 46 is its Flamsteed designation.
We've talked about Flamsteed before, and I do appreciate one thing, is that he doesn't even try to rank brightness. Like, he just goes straight geometry. The designation system is based on the order of right extension within each constellation. So he's like, this is the way it goes.
Well, there is a bit of a problem with it because of the wibbly wobbly precession, but it's at least easier than relying on old Bayer eyes.
Pros and
Yeah,
cons. Yes, indeed.
it's hard to rank order things in the night sky, is what I've learned so far. So 46 Leonis Minoris is also called Praecipua, which means the chief, except it sounds like it's a little confusing because it sounds like that IAU name was actually supposed to be for 37 Leonis Minoris, but it was transposed supposedly in 1814 by Giuseppe Piazzi. And the IAU was like, whatever, we'll just leave it with 46 Leonis Minoris and we'll give it this formal name as well. So,
You make one error in your hand drawn atlas, in your star atlas, in the 1800s, and that becomes canon. That's just how it is.
yeah, it kind of seems like it. But this star is between 95 and 100 light years from Earth. It has a visible magnitude of 3.83, and it's suspected to be a variable star. It's a K type star, and it's described as being in that red clump stellar evolutionary stage.
There's so much I have questions here, Kit. Okay, yeah, remind me, what's a red clump?
Yes, it's a not a charming name as we discussed before, but it describes the clustering of red giant stars on the HR diagram.
Oh, all right. So let's think of Jordan's best ways of remembering what HR diagram is.
Uh-huh.
First guess. Hertzprigel random.
Try again.
All right. Heebie jeebie roby goby.
Another really, really close guess.
It turns out HR diagram, which I should remember after 3 years of doing this podcast, stands, of course, for Hertzsprung Russell. And how I've missed you both.
Of course. So these red giants are around 5,000 degrees Kelvin and have a positive zero point 0.5 absolute magnitude. So they're a little hotter than usual red giants of a similar luminosity. They're also often used as standard candles to measure distances because of the nature of their luminosity.
All right, 46 Leonis Minoris packs quite a punch. That brings us to our segment, Bayer's Variable Star, where we follow the Greek alphabet to explore the Bayer designated stars of the constellation. Last month, we were at Epsilon Camelopardalis, which didn't exist. And as we mentioned earlier today, the only Bayer star that does exist here is Beta, as we've previously discussed.
Yeah, this segment is growing a bit fraught, I would say.
When things get fraught, you know what we do? We find variable loophole.
Is that right?
We are the rule makers of this podcast, after all. If we can't find variable loopholes, who can?
Oh, okay. So what's the loophole this time? Are we gonna do a different variable star? What do we have?
Well, Kit, we've used that loophole before, and I think
Mm,
it's important for us as podcasters to find new variable loophole.
right,
That's the whole point. You know what?
right.
They're variable. So no, my variable star is going to be, and you'll know this one by heart, right? HD 82886.
Oh,
Strike
of
a chord.
course. Yeah.
Well, you might also know it as Illyrian.
Okay, I don't know this one, but I do know it's not a variable star. So what's its deal?
Well, Illyrian HD 82886 is a K-type star. It's approximately 414 light years from Earth. It has a visible magnitude of 7.6 and an exoplanet with a gas giant planet over twice the mass of Jupiter.
Okay, we got a super Jupiter here.
Super Jupiter, super Jupiter. Exactly. This super Jupiter was discovered in 2011 and is called HD 82886b
Mm,
or Arbor,
mm,
Arber.
mm.
On average, Arbor is 1.58 astronomical units AU from its star and completes an orbit in 1.9 years.
I love an exoplanet.
Absolutely.
It is kind of surprising that the star and the planet have names since the star isn't visible without a telescope with a visible magnitude over 7.
And that's kind of the reason why the system was selected, because there is another star in Leo Minor with a similar super Jupiter planet.
Interesting. Go on.
In 2019, the IAU organized Name Exo Worlds 2, which, if you can believe it, was preceded by Name Exo Worlds 1 in 2015
Mm,
and eventually was succeeded by Name Exo Worlds 3 in 2022.
mm.
And in 2019, in Name Exo Worlds 2, countries were assigned a star with an exoplanet, and people in that country submitted potential names.
Hmm.
These great names like HD 82886 and HD 82886b were assigned to Albania. The name of the star, Illyrian, which we discussed earlier, is the name of the ancient peoples who lived in this Balkan peninsula, and the planet's name, Arbor, Arber, was the medieval term for those who lived in Albania.
Oh, I do like the idea of the IAU getting input on the names and not just using Greco Roman mythology as a source. Yeah, I definitely did not know about the Name Exo World events, so I wonder if there'll be another one sometime in the future.
Variable star segment. We still got it. Let's take a quick break and then we can find out what won Kit's gold star this month. Welcome back. This segment is called Gold Star. In this segment, we alternate picking the star or space object in our constellation of the month that captures perhaps our mind, our heart,
Mm-hmm.
and at best case, our soul.
Mm.
So, where'd you go with this one, Kit?
So there are actually a few really beautiful and strange deep sky objects in Leo Minor, including a galaxy with a supernova imposter. There is NGC 3003, which was featured in Alton Arp's Atlas of Peculiar Galaxies. And there was also NGC 3504, which is a starburst galaxy. So there was definitely a lot of choices.
Lots to choose from.
And of course, I'll post pictures of these other ones over on our socials at Storytime Pod on the Universidon server of Mastodon.
I love this Storytime social page, and we are bringing you all the astrophotography. So, be sure to check it out. But, Kit, let's get down to the nitty gritty. Who won your gold star for Leo Minor?
So I decided to go with Hanny's Voorwerp.
What, Kit?
Uh huh.
What's a Hanny? And who's a Voorwerp? Wait, say it again.
I think it's Voorwerp. Voorwerp.
All right, so who's Hanny and what's a Voorwerp?
So the Hanny in question is Hanny van Arkel, who is a Dutch school teacher who participated in Galaxy Zoo.
Galaxy Zoo. Yes, we talked about this before. It's a citizen science project.
Mhm,
That could be you or me or anyone,
mhm.
where individuals volunteer to look through images of galaxies, and then we do our best to classify them or flag them for further evaluation.
Exactly. So, something like the Sloan Digital Sky Survey produces tons and tons of images, and computers aren't yet so good at classifying them. So, Galaxy Zoo is a way of outsourcing that work to people who are interested in seeing these types of images. The first one was in 2007, and the projects are sort of ongoing with various kinds of astronomical data.
All right, Hanny von Arkel, a Dutch school teacher. What did they find?
So, Hani is probably right instead of Hanny, but I'm going to go with Hanny. So Hani was looking at a galaxy called IC 2497, which was a spiral galaxy in this constellation Leo Minor. But she noticed a big sort of glowing glass cloud near the galaxy that seemed as large as the galaxy itself. It was strange, and so astronomers took a closer look at it. And when I say astronomers, I mean they looked at it with the Hubble Space Telescope. They pointed it in that
Damn.
direction. Mhm.
That's how you know they got your attention. Yeah.
That's right. And so the object got the name Voorwerp, which is a Dutch word for small object. And it turned out to be a quasar ionization echo.
All right, Kit. I'm just going to try to
Uh-huh.
synthesize this as a listener. Quasar, ionization echo, Voorwerp, unfamiliar to me, but both very compelling names. Different vibes. What are we actually talking about here? What exactly is it?
So, according to Dr. Chris Litnot's book, Accidental Astronomy, which, as an aside, I really highly recommend, it is a great read. He writes that the Voorwerp is glowing because 50,000 years ago, IC 2497, that galaxy, had a quasar powered by an active black hole, which was, of course, eating things up and causing magnetic fields to fling things about. Ultimately, this caused the gas in the Voorwerp to glow, even though the black hole in the galaxy isn't currently active. So Hanny's Voorwerp echo of light will eventually disappear, but it's really just this reflection of this process that was going on in this interaction between quasar and the galaxy around it and near to it.
Hanny's Voorwerp has it all. We got mystery, we have citizen scientists, we have ethereal beauty. So, welcome to the Gold Star of the Month. That brings us to the end of our exploration of the cosmic background for the constellation Leo Minor. Next week, we'll be exploring lions and folklore and creating our own myths for this constellation, since it doesn't have a Greco Roman myth associated with it.
This has been Kit,
And Jordan,
sisters who love stars and stories,
and we'll see you next time.
on Starry Time.